Young's modulus. Young's modulus is a material property that describes the stiffness of an elastic object. It gives the ratio of deformation over the original length of a material, which is an effective way to characterize materials. Knowledge about the Young's modulus of materials enhances the selection of materials for particular application. Here, we are using the Searle's apparatus to measure the Young's modulus of a given wire. Materials required: Searle's apparatus, 2 wires of same diameter and length, meter scale, screw gauge, 0.5 kg dead load, 0.5 kg weight hanger, and slotted weights. Principle: according to Hooke's law, within the limit of elasticity, stress applied is directly proportional to the strain produced. Here, the extension produced by the wire is directly proportional to the load attached to its end. Now, Young's modulus of the given wire can be measured using the relation Y is equal to normal stress divided by longitudinal strain, which is equal to mgl divided by pi r square L, where capital L is the length of the wire, small l is the extension for a load m, r is the radius of the wire, g is acceleration due to gravity, m is mass added in the weight hanger. Procedure: calculate the least count and zero correction of the given screw gauge. Measure the radius of the wire using the screw gauge and find the radius of the wire. Measure the length of the wire using a meter scale. Tighten the 2 wires on the torsion screws of the Searle's apparatus. Fix the experimental wire on the right frame and auxiliary wire on the left frame. Suspend the dead load on the left frame and weight hanger on the right frame. Now, we have to find out the pitch and least count of the spirometer. For this, rotate the spirometer screw 2 times and note the corresponding pitch scale reading. It is noted that the distance travelled for 2 rotations is 2 millimeters. Then, pitch is equal to distance travelled divided by number of rotations is equal to 2 millimeters divided by 2, which is equal to 1 millimeter. Now, the least count of the spirometer can be found using the relation least count is equal to pitch divided by total number of divisions on the circular scale, which is equal to 1 millimeter divided by 100, which is equal to 0.01 millimeter. The central screw of the spirometer is adjusted in such a way that the air bubble in the spirit level is exactly at the center. Note the head scale reading of the spirometer for zero load in the weight hanger. Add 0.5 kilograms weight to the weight hanger. Now, the wire extends and the bubble is then shifted to the left due to greater weight in the right side. Adjust the central screw again to make a bubble at the center and note the corresponding spirometer reading. We can repeat the above process by adding weights to the weight hanger in equal steps of 0.5 kilogram. Note the reading in each case. Now, remove one 0.5 kilogram weight from the weight hanger. It can be noted that the bubble shifts to the right side. Bring the bubble to the middle by adjusting the central screw and note the readings. Repeat the above process by removing weights in equal steps of 0.5 kilograms. From the observations, we can find the extension L produced by the wire for a load M. Now, the Young's modulus of the given wire can be calculated by using the equation Y is equal to mgl divided by pi r square L. Applications. Knowing the strength of a material is essential in many industrial areas. For example, When constructing steel bridges, stiffness of the metal should be guaranteed to resist bending and should have a high tensile strength to carry the weight. Also, in designing cars, materials should be selected in such a way that they are ductile enough so they can be easily and economically plastically deformed. Additionally, materials should have enough stiffness to retain their shapes or resist bending. Young's modulus. To determine the Young's modulus of elasticity of the material of a given wire using Searle's apparatus, materials required for this experiment are Searle's apparatus, 2 wires of same length and diameter, .5 kilogram weight hanger and slotted weights, 0.5 kilogram dead load, slotted weights, screw gauge and meter scale. Hang the dead load on the left frame and weight hanger on the right frame. To find the least count of the sperometer, rotate the central screw 2 times and note the scale readings. Least count can be calculated as 0.01 mm by using the relation LC is equal to pitch divided by number of divisions on the circular disc. Take the screw gauge from the table. Least count of the screw gauge can be calculated as 0.01 mm by using the relation LC is equal to pitch divided by number of divisions on the head scale. Measure the diameter of the experimental wire using the screw gauge. Note the screw gauge reading and calculate the radius of the wire. Measure the length of the wire using a meter scale. Adjust the central screw to shift the air bubble to the middle. Note the sperometer reading. Record the value in a tabular column. The air bubble is now placed at the center. A 0.5 kilogram weight is added to the weight hanger on the right frame. The wire extends and the bubble shifts towards the left. Adjust the central screw to shift the air bubble to the middle. Note the sperometer reading. Record the value in a tabular column. Add a 0.5 kilogram weight again to the weight hanger. Note the sperometer reading after adjusting its central screw to shift the bubble to the center. Record the value in the tabular column. Repeat the process by adding weight in equal steps of 0.5 kilogram and record the observations. Remove a weight from the weight hanger. The bubble now shifts to the right. Fix it at the center by adjusting the central screw and note the sperometer reading. Repeat the experiment by removing weight in equal steps of 0.5 kilogram and record the observations. Calculate the extension produced each time and then find the Young's modulus. The mean of the calculated values give the Young's modulus of the material of the wire. Calculation of Young's modulus of the wire for a load is 0.5 kilogram. Plot a graph with extension along x-axis and mass along y-axis. Calculate Young's modulus of the material of the wire by using the slope of the graph. By calculation and from the graph, Young's modulus of the material of the given wire is calculated as 1.903 into 10 raised to 11 Newton per meter square.